May each new day find us learning from the past, working towards the future, facing the sun, and grateful to all. Good morning, all. Welcome you for the International Virtual Conference on the Applied Data Science and Intelligence Computing. Let's invoke God's blessing through a prayer song followed by a prayer.
Prayer. Dear God, you are with us in every transition and change. As we enter into another day with excitement and even some anxiety, we recall your deep compassion, presence, and abundant blessing. We thank you for the gifts, talents, and skills with which you have blessed us. We thank you for the experiences that have brought us to this moment. We thank you for the work of others that gives breadth and depth to our own work. Be with us as we move forward, rejoicing with you and supporting one another. We ask this in your holy name. Amen.
Now, I invite Dr. Shobna R to welcome as guest speaker Dr. Srinivas Perumal R.
Good morning to one and all. On behalf of the Department of Computer Applications, it is my pleasure to introduce our chief guest, Dr. Srinivasa Perumal, Associate Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. He has completed his UG degree at Jawahar Science College, Neyveli, Master degree at Faculty of Engineering Technology, Annamalai University, MPhil degree at Bharatidasan University, MTech at Ramanujam School of Mathematics and Computer Science, Pondicherry University, and PhD in Computer Science and Engineering, EIT Delhi. His doctoral study focus on investigation on some local descriptions for face analysis. He has more than 20 years of experience as an assistant professor in different colleges. He published and presented 19 papers in international conferences and published 4 book chapters. He organized national and international conferences and acted as academic coordinator, NAC committee member, assistant dean, and acting as one of the university level coordinator for VIT IQAC Chennai. We welcome you, sir.
Good morning, sir. You can take over the session, sir.
Microphone on monitor. Thank you. Am I audible? Very good morning. Shall I start the presentation? Yeah, thank you. Very good morning to one and all. Today we are going to discuss about a small real-time application-oriented topic as challenges and opportunities in data visualization. Actually, before we are going to discuss about that challenges and opportunities in data visualization, first we know that what is data visualization. Actually, the data visualization is the one of the important for the entrepreneurs and then the people, those who are doing analysis. The reason behind this, if you are instead of reading all the document, or if instead of going through all the data with us, in particular situation, it's very difficult because the data is not in a small data. Now we are working with a big data. So in the big data, if you want to do any analysis or if you want to just go through the information, what exactly it is in that particular data set, it's very, very difficult. So that is the reason why people are going for a data visualization. Actually, the thing is, instead of reading a book or instead of going through the document, if you visualize something, if you see something as an image, our brain easily observe that. So due to that only, people are trying to visualize everything in the image format, defined in the image format, particularly in the big data analytics. One of the good example for data visualization is Google Map. Instead of seeing the address, so directly by visualizing that, the way, route, path and everything, we are reaching the destination. So it's a uptrending one in the current field. So that is what I chosen this topic in this particular conference. Visualize, to form a mental vision, image or picture. It will help us to understand what exactly in that. The one kind of problem is in this, while visualizing, sometimes there is a chance of misinterpretation. Chance of misinterpretation means if I'm showing something as an image, people may not able to understand exactly what is it, that image. That's why in the childhood we used to read the cartoon books. In that cartoon books, small descriptions they will given with the image. So that small description will help us to understand what exactly in that image. So the image with a description. The description is very brief description. So with that, we are able to understand what exactly that image defines. The same thing now we are taking into the data. So if the data may, the Excel sheet consists of 10,000 or 20,000 or 30,000 data. For example, we can take as a student information system. We want to know that who will be a topper in the class, or what will be the average mark in the class, what will be the lower mark in the class. So in that time, it will be easy to understand if something is like in a graph, instead of providing the Excel sheet to the management. If you are presenting in the graph, people may understand exactly what is in that within a second, instead of explaining all the things. So that is what people are moving to the data visualization. Visualization is nothing but we are making whatever we did, that we are going to present in the image format. So that will help us to understand the concept in easiest way, because our human brain is in that way. So that is what we are going for a visualization. Visualization is the use of computer graphics to create a visual images which aid in the understanding of complex, often massive representation, big representation of data. We are going for that. So in this data visualization or information visualization, used to interrupt in the right way and gain the what kind of data is that, who will be the audience of the data, how we are going to process the data, what will be the outcome of the data. So that and all we are going to see by visualization. So that kind of the things, for example, black diagram will help us to understand the process of the particular method. So it's a kind of visualization, the information visualization. Okay. So this is actually through visual representation, often interactive of a raw data. So if you are going for a data visualization, 1 minute. If you are going for a data visualization, Madam, Anita Madam. Hello. Hello. Madam. I'm audible, madam. Okay, thank you.
Sir, kindly present in full screen, sir.
Sir, madam, full screen.
Yes, sir.
It is not in the full screen?
No, sir.
1 minute, madam. Actually, I used the slideshow only, but...
Okay. Okay, sir, you can continue.
No, madam, no problem. 1 minute. Give me a minute. Is it now? It is in the full screen, madam?
Yes, sir.
Thank you.
Thank you, sir.
Yeah. So before we are going to create a data visualization, we should think about that, what we are trying to communicate, to whom we are trying to communicate. So because based on that only, we have to prepare the data. So sometimes the data can be small data, maybe a less data. Sometimes it may be a huge data. So how we are going to communicate that data to the people or to the audience? Okay. So in that way, we have to determine that what we are trying to communicate and what will be a better visualization method while communicating the data, which will be an easy to understand. Okay, and thinking about the sound. Actually, sound, this is purely suited for a visualization of data when comparing with the visualization, because seeing an image or hearing something, sometimes while hearing, if you are disturbed or sometimes we may miss that particular line, or due to the pronunciation problem, we may not be understand what exactly they are trying to say, what exactly they are trying to communicate. But image is not like that. Whoever may be, the language doesn't matter in the image. If the content is a self-explanatory content, then it will be easy to understand. So that's what, while creating data, we need to be very clear, we need to be very precise what we are trying to communicate and whom we are trying to communicate, what data we are going to use, and which type of diagram or that chart we are going to utilize to visualize the particular data. That will be very, very important. That should be very clear. Then only the people, the audience will understand exactly from that. Otherwise, it may create a problem. So we need to be very, very clear in that before we are going to create a data visualization. So why we need to depend on vision? As I mentioned that sound is then a problem. So vision will be one of the best thing here. So that's what we are moving to the vision. The human brain, the human visual system is a high bandwidth, okay, to the brain. So the brain will react immediately if he sees something as a video or something as an image. Okay, if it is a sound, it's not good. Taste, no. But vision means any visual effects, our brain will immediately reflect. So that's what people are preferring vision rather than the reading a document or listening a thing. So generally we used to say that if you listen the things again and again, we will be very effective in that particular thing, or we will be good in that. Yes, true. We need to listen again and again, because sometimes if we missed one or two sentences, we need to recall that, and we have to again we have to listen that. Then only we can able to get the continuity. Otherwise, the continuity will be missed. But image, it's not like that. It will be easy to understand. So that is a subjective experience of seeing something. We'll grab everything immediately, and then processings and then attentions will be very clear. So the people are good in visualization. That's what we are depending on, vision instead of rather than sound or taste or something else. We are preferring a vision. In this, we need to consider while we are creating a data visualization. Yes, we are going to design a data visualization. Before we are going to design a thing, we need to consider that what type of data you selected, whether that particular data will support you to obtain your objectives. Okay. Who will be your audience? How you are going to encode the data? Because if it is a large data, big data, we are not going to use all the attributes. So which are all the attributes is really supported for the particular problem. If you are taking a student information system, in the student information system, many parameters will be there. All the parameters will not be supported for all the presentation. Suppose if you want to identify that the diversity of the student, that time the mark details and all not at all required. So we can skip that particular thing. The CGPA, GPA, it's not at all required. We can skip that. So which will be our objective? Based on that, we have to select the attribute instead of selecting all the attribute in the particular from the raw data. So we have to design what type of which attribute we are going to be selected, how we are going to use that particular attribute. So that is what we have to mention here. How will you encode your data? How we are going to structure the visualization? What is the relationship between the data? We need to demonstrate the relationship between the data. Simply, if I am student information system, I want to display all the data. If they are asking, means it will be a very clumsiness. So that clarity will not be there in the particular diagram. So what we have to do means, according to our objective, we have to define the particular informations instead of rather than selecting all the attributes. And we have to scale it, prioritize it. Okay, and how we are going to interact that to the user. So normally we have to, if you are going for a univariate data, or you are going for a bivariate data, or if you are going for a multivariate data, how you are going to visualize that? How you are going to say that this data mentioned this and that, this, that. For example, multivariable data means if you are taking as a world, in the world, a river, we have to classify that which is a river, we have to classify that which is on a pond, we have to classify that which is on a mountain, we have to classify that whether the land is an empty land or it's a constructed land. So in this case, we have to give different colors. So the color will explain this is on a mountain, this is on a river, this is on a flat, this is on an empty land, this is on a pond. Similar like that, we have to classify it. So the color is the one of the way for defining that particular thing. So it's like that we need to interact. That clarity is very important. Instead of that, if you are giving an image without describing anything or without mentioning any legends, so that will be a problem. Okay, so that should be very important. Okay, so that will help us to understand the people what is in that. So these are all the consideration we need to keep it in our mind while you are going to create a data visualization. What will be the if I defining the same thing in the table or graph, which will be a better one? Actually, table is one of the way for representing information. Graph is the another way for representing an information. Generally, people will prefer table because we can store more informations in the table. But graph, we can define only limited informations. We can't define more information in the table. Graph. And while if you want to search something, the table is somewhat easier than graph by searching. So that is what the table is best when you need to search specific values or when you are going to look up some particular things. Lookup is nothing but search. We are going to search something in that. Okay, users needs a precise values. Yes, we can do that. We can compare the values easily. We can compare the values. We can store multiple data there. Okay, so even if we can store all the attributes, whether it is related or unrelated, whatever the attribute is required, we can keep it in the table. But the graph is not like that. Graph should have a shape. The graph should have a shape means it may be consist of a bar diagram or pie diagram or something. It will be like that. In that particular shape, we have to mention that what kind of relationship between these two data, x-axis and y-axis, or z, if we are going for a multivariable data. So then we have to mention that what will be the relationship between each axis. And here, advantages that we can show the trends which will be as good, which will be in a bad, but in table it is not possible. Okay, and then we can use for large data set, but not for all parameters. Okay, so the thing is, a graph or table is good for data analytics. Graph is also good for data analytics. Table is also good for data analytics. But the thing is, as a developer, we need to decide whether we are going to represent in a table or we are going to represent in a graph. So sometimes we can't represent everything in the table. Whatever items in the table that we are trying to simplify and we are trying to show it in as a graph. So the graph will be more effective in visualization rather than the table. But table is more effective in storing information rather than the visualization. So okay, so that is the thing we need to understand when it will be suitable, table or graph. So the resource limitations, if you are going for a visualization, as a developer, we need to keep it in our mind. What are the limitations we are facing in the visualization? The first one is computational limits. Yeah, time and then memory. Obviously, we know that if you are going for an image rather than the table, definitely the time as well as the space will be more. So if you are going to process something in that, obviously we are going to spend some memory for the image. Okay, so that is the one problem in related to computer storage. Another one is, if you are coming for a visualization, the pixel representation. I will take again a Google map. If I want to see in Google map, if I want to see the complete image in a particular window, it's very, very difficult. In that, we can't get anything properly. Maybe we'll get an overview, but if I want to make it something in detail, then that will not be sufficient. So that is the problem. Then we have to zoom it. Either we have to zoom in or zoom out. We have to do that, or we have to move this side to left to right or right to left. So based on that only, we will get exact things in that. So these are all the problem in the visualization. If it is a small small data, then it will be good. If I am going to work on with that bigger one, then it will be a problem. So it's a problem, but it can be overcome by using a zooming or panning. Then we can be reduce it. Okay, so there is a chance of viewing all the things. Only the thing is we can't see it in the simple image. Means we have to zoom it. From that we can extract the informations. Okay, that is what they mentioned, that the ratio of space used to encode that unused space and used space will be the problem in that display. Coming to the human limits, problem with the time of human, the memory of human can't remember all the things, and then we can't be patient for a long time. Okay, so sometimes we may lose our attentions, so that also will create a problem. So that can be overcome in the things. So advantage of the thing is we can easily share the informations. We can explore more opportunities from that. We can see that relationships and patterns. But these are all the good things. Coming to that disadvantage of data visualization, we may not get accurate information because the perceptions may vary. Sometimes in the image, it defines 5.5 or 6. People may think that if it is not scaled properly, 0 to 5 or 5 to 10, even if you are keeping 6, sometimes people may note that it is on a 7. So that is a problem in the understanding and then scaling. So that should be overcome, and that should be rectified if you are designing a visualization, data visualization. And then correlation does not allow mean causation. And then sometimes while we are communicating, we may lose the core informations. Maybe people may not understand properly. That is what I said, that the interpretation of the people is very, very, very important. Even if you describe something, so as a human, sometimes we may understand from the image or from the text. They may say it in some other way, but we take it in another way. So it will end with the negative one. So okay, so that kind of the things will be disadvantages, because here human intervention will be very, very important. If the human intervention is there, the human can present in right way, they can explain the things properly. But by seeing an image, sometimes the information's loss will be there. So that will be a problem in data visualization. If it is good for understanding, easily we can share all the information, but even though how the human perception also here will cause the problem. So the human perception is very, very important in the data visualization, in understanding the data in a right way or otherwise. So that is what generally people is expecting, or the people are human intervention is required to explain wherever that the perception goes wrong. Okay, so human without human intervention, we can't take any decisions. So human intervention is very, very important in taking a decisions in the data visualization. I hope you understand. If you have any doubts, please. Okay. Next is data visualization. Generally, this charts are using for data visualization. This is a chart which is available in our Excel, Microsoft Excel itself. So Microsoft Excel is also one of the data visualization tool. It's one of the data visualization tool. So bar chart is one of the method for visualizing the data. Line chart is one of the method for visualizing the data. Pie chart is one of the method. Bubble chart, stacked chart. Stacked chart is used for multivariate purpose. For single variate purpose, we will use the area chart. For stacked chart, we are going for a multivariable purpose. Similarly, stacked line is there, stacked bar is there. We are using that. And then scatter plots. These are all the basic data visualization types for representing your data in the graph format. So this is the thing. Apart from that, as you mentioned that text visual, as I mentioned that Google Map is one of the data visualization type. Another text visualization type is there. So for retrieving a text, how they are capturing the text. So tree structure is one of the text visualization technique. So tree structure also can be used for a data visualization purpose. These are all the methods, models available for visualization. In this visualization, we need to be very clear what type of chart will be used. Sir, I can use a line chart for everywhere. I can use a bar chart for all type of data. No. There is a constraint. There is a limitations in using a charts. Okay. When we can go for a line chart, when we can go for a bar chart, when we can go for a scatter plot, these are all very, very important. So we can't use all the chart for all the time. Pie chart, we have to differentiate. So whenever the proportionate, we are going to define that proportionate between that variables or proportionate between that particular data set. Then we need to go for a pie chart. Okay. If you want to make it a relationship between two variables, whether those two are similar or different, or I want to categorize it, I want to classify that, the data, then I can go for a scatter plot. I want to know that if the data is in a categorical data, then I can go for a bar diagram. If the data is in a sequential data, then I can go for a line diagram. So such kind of things are there. We need to define that. If you are going to select a chart, that chart, before you are going to select the chart, we have to analyze the data. What type of this data? This data is in a categorical data, it's a sequential data, or we are going to classify the data, or what kind of data is that? Based on the data only, we have to select the chart type. We can't use all the charts for all the data. Sir, if I can use a line diagram, a bar diagram for a pie chart for a same set of data, yes, we used in Microsoft Excel, we used that. But that is not correct. That is not at all correct. We need to understand the data type. And according to that, we have to select the chart method rather than selecting all the chart for a single data. What we will do means we will see that which data will be, which chart will be help us to understand the information properly. Accordingly, we used to select the chart. We are not bothered about that, what kind of data is that. But if you are coming for that big data, or if you are a data visualization designer, we need to be concentrate on that, because we know the audience. That's what, based on that and our understanding, we are defining the chart method. But here it's in a global one. Everyone should understand that properly. So that the model should be based on the data. So for particular this data, here one column is in a year, another column is in a sales. So from this we can understand that, okay, 1919, the data value will be a 2000 and plus. Generally we used to say that 2000 plus, but here exact data is 2110. So if I want to make it this, I can mention that value in top of the diagram. In the bar chart, in the top of the diagram, if I mention the value, easily I can understand. Otherwise, if the information is like this, so as a third person, I may say that if I don't have this table with us, I may say that 2000 plus. 2000 plus. What is the difference between 2000, 1999 and 2000? I don't know exactly the difference between that. If I have a table, I can say that that is the -5 will be the difference in 2000 and 1999. But without that value, if I'm seeing this image, I may not get proper, accurate information. That is what we say that it's a disadvantage. So in this case, we have to put we have to mention the value in top of that particular diagram. If I mention the value in the top of that particular column, each and every column, then it will be full-fledged visualization data. Otherwise, this chart will not support me to understand what exactly in the data. I can understand 1999, 2000 plus, 2020, 2000 plus, 2001, 2000 plus. I don't know exactly what is the difference between each and every year. So for that, title is very, very important. Otherwise, this data may not be in a better visualization. When it will be in a better visualization means if the title is there. One thing is title is this axis title. Yes, axis title is okay, sales. Here, people may understand that it's in a year, but what will be the value? That value is the main important information in this particular chart that is missing. So due to that, this data may not be in a better visualized data. If you want to make it in a better visualized data, you have to mention that value of each and every year. Then only the data will be in a better one, visualized one. So we need to keep it as a designer. We need to keep it in our mind before we are going for a data visualization. Okay, that's all about introduction of data visualization. So far what we discussed is what is data visualization, what are the things we need to be considered, factors we need to be considered if you are going for a data visualization, designing a data visualization, and what are the advantages and disadvantages we discussed so far. So now coming to the challenges. What are the challenges in data visualization while designing? Apart from that, what are the challenges are there? So for any project, based on the project concept, based on the data characterization, that means each and every data, because we are, as a data visualizer, we are going to concentrate only on our data. So data characterization, we are trying to map the data. Based on that, we are going to present the data. So after the data presentation, the visualization will be developed and it will be deployed for the use. So this is what actually we are trying to do in the data visualization. In these challenges, adapting to data changes. Adapting to data changes, it's one of the challenge. And then anticipating the test cases, edge cases, test cases, what are the test cases might be. And then what will be the technical challenges in understanding the data, and how we are going to make dependencies in between the data, articulating the data matrix. Okay, how we are going to communicate, because we need to communicate the information properly, what exactly in the data. Then only it will be good. Otherwise, the data visualization will not be and people will not understand the project properly. And how we are going to preserve the data. So these are the 6 challenges in data, designing a data visualization. for a project, for any project. Okay, first one, adapting to data changes. I have a data with me. I know each and every data character. So what will be an attribute? What will be a data type? Which data for which purpose? Everything in my hand. So I know very well about the project. I know about the data set. So I'm good in that. Okay. So in this case, if something I want to add, the people want to add, if it is data is in a dynamic data, okay, it is not in a static one, it's in a dynamic data, or some modification is required. Sir, the data is a raw data. I want to completely modify. I want to do all the pre-processing. So after pre-processing only, I want to make this data for data visualization. Yes, as a data visualization, we have to analyze the data. If the data consists of noise, or the data contains noise, or data contains any missing values, so we have to do the pre-processing. So after pre-processing, the data should be cleaned. With that cleaned data only, we are going to visualize the data. So in this case, if any modification occurs, how we are going to adapt it? It's a challenge. Sir, if that data is a very clear data, after pre-processed, if I started to do the visualization, but after that, people want to add some more data before that, yes, we need to accept it. So in this case, it will be a challenging one. Again and again, modifying a data will be a challenging one. So that's what they said, that the impact of such effects may not be clear to data providers, because data providers, they don't know the process involved in pre-processing. Simply they will give data for us, but as a developer, designer, we need to pre-process the data and we have to add with that existing data. So this will be one of the challenge. Next challenge is anticipating edge cases. Edge cases are what? Test cases. We need to test all the possible combinations. Actually, one of the software testing myth is 100% testing is possible, but that is a myth. There is no chance of 100% of testing. Even if it is a small program or large program, if you want to test all the possible combination of test cases, it may take more time than development, or we can spend more time for testing itself. So whatever the time you allocated for your project, that is not sufficient for testing alone. So that is why people will not do 100% testing. They will follow some model, and according to that model, they will test the data. They will not do 100% testing. Similarly, here, if I want to use all test possible combinations, it's very, very difficult. It is not easy to do that. But another way, I can anticipate that test cases based on my experience, or the people, their experience, they may anticipate that what kind of test cases is very, very important. According to that, they will do the testing. That generally we used to call as a random testing. So that might be sufficient in test cases. But doing all test cases is not possible. So that time, sometimes we may miss some important test cases. So what people will do means, from that experienced people, they may ask what are the things need to be tested, and accordingly we need to test all the things, and we have to deliver the product before deployment. And coming to that technical consideration, designers may not be aware of all the technical constraints, because the developer knows about the technical constraints. Designer is not good in technical aspects, but he have the basic knowledge of technical things. So but with that basic knowledge, he may design something. Okay, but in coming to the development phase, it may create a problem. So what we have to do means we have to be very clear. That is what generally in software testing, they used to test the product in each and every phase, after requirement, after designing, after development. So after designing, if someone tested properly, then this problem will be resolved. So the technical, we need to train the designers in the technical aspect also. According to that, we can extract the information, but this can lead a uncertainty about design feasibility and can trigger more revisions in development, but this should be avoided by giving training to the designers. Articulating data dependent interactions. Here we need to, articulating is nothing but mapping data dependent. Wherever the data dependency is there, we need to map that. So sometimes the designers generate a variety of data in accurate views for multiple states, but this may lead the development cost extra as well as design cost extra, because in that more coupling, in that more dependencies also will be a problem. So wherever the dependency is required, we have to make the dependency. Wherever the dependency is not required, we should not depend the data. So what we have to do means we should be very clear in the making a relationship between the data. So while making a relationship data, if you are making a more relationship with that for a data, means definitely the data will be more complex. That will create a huge problem in it. It will be more secured or it will be more good, but the more it will create a more complexity. So that more complexity will create a problem for us in the future. So that will be another challenge in the visualization. Coming to that, how we are going to communicate this data mapping. So okay, now dependency is created. Now we need to communicate each and everything to that. Okay, so here we explain more detail about each and everything. That's what they mentioned, that precise informations and complete specification of data we need to be defined, but that is not possible at all with the present design tools. The present design tools is not sufficient to be sufficient to make it very precise informations while communicating. Okay, so that will be a problem. So that should be overcome. And finally, preserving data mapping by integrating across interactions, iterations. So this is another serious issues. So that should be overcome. This problem may not be noticed until the product developed. After the deployment, only people may understand that where the mistake is there. So such kind of misinterpretations problem should be avoided. So this also will be a challenge. These are the 6 challenges. So from these challenges, only we are creating an opportunity. So challenges brings an opportunity to do that. So what are the challenges? Data, adapting a data. Why it is the problem? Because the problem is we have used all the data, means this problem will become. So here we have to reduce the data. The data reduction is very, very important. So this data reduction is one of the opportunities in data visualization. We have to understand what type of data, what variable we are going to use. So based on that, we have to take a sampling and we have to apply the pre-processing steps, and we have to use that particular information. From that, we will produce we can reduce and optimize the informations. So once if you optimized the informations, that informations might be overcome over the challenges. Okay, and then reducing latencies. So the spacing is another problem. So that should be thing is, so either by zooming or drag and drop or panning, we can reduce the latencies. By that, we can understand the things on that. So these are all the opportunities in this data visualization. Coming to that visualization tools, what are all the visualization tools are available? As I mentioned, Microsoft Excel is one of the tool available in Windows. It's open to all. Okay. So in that, it's a licensed one, and if you it already built in, so we are using that in Microsoft Office, MS Excel. In that, we are using chart types. So all the chart types are available in that. So we can use that chart type for visualization. This is the one way of visualization. Apart from that, Tableau is there. It's a open source, okay, but limited versions, limited features. Open source is there, so we can use the Tableau for how to arrange the table, how to present the spatial domain. Actually, in Microsoft Excel will not support it for spatial domain, but Tableau will support it for spatial domain. So we can use that for a spatial domain, or text visualization, or data visualization, or information visualization. For all kind of visualization, Tableau will be supported. It's a open source, and it will be for limited resources. Okay, and Infogram is the another tool that is also in an open source. Okay, and chart blocks, data wrapper, Google Charts, JavaScript, Sigmages, or not only this, Orange, several data visualizations tool is there. So in that, that tool will support us to visualize the data. Only thing is, before visualization, the data analysis is very, very important. We have to analyze the data. According to analysis, we can visualize the data. Yeah. These are all the references, actually questions. Thank you. Any questions, please? Any questions? முடிச்சிட்டேன்.
Participants, any queries?
What should actually, for missing values and suspected informations, we have a data analytics algorithm is there. We can use that algorithm to remove the missing values or remove the suspected informations. Several algorithms are available for that. We can use that algorithms, data mining algorithms, or data analytics algorithm for that. Thank you, madam. Yes, madam. Yeah. Yeah, 1 minute. I'm visible. No, right. Yeah, which is the most easiest way to finding missing. Actually, in data, we want to identify the missing values from the data set, or hello, which is the actually missing data set means if different in each and every column there will be a zero values or any hyphen values. For example, if one in class 30 students are there, out of 30 students, one students may not be attended the exams. Faculty may not marked as absent, or they may not marked as zero or hyphen. So there may be there is a chance of zero or hyphen. If present zero is a data, exact data. If it is hyphen means we can easily identify that, or if the information is left without defining anything in that particular row, that can be called as a missing data. What process we can use transform raw data into visualization? Actually, visualization, we can't convert raw data into visualization. First, raw data means it's a original data, the data which we collected from the collected directly. So that information, it may not be a proper information. From that, we need to do the pre-processing step. So we have to do the data analysis. Data visualization is the process which will help you to understand the data which is available. So conversion of raw data to visualization means we have to do pre-processing. Through that only we can visualize the data. Yes, data visualization capable of large number of data points. It's true. Yes, we can. The only thing is the number of axes is very, very important, and the way how we are going to representing the particular data is then important. But we can work with the large number of data points. That is the reason people are using for big data analytics. Big data or data, we can analyze, identify the missing data. It will not be a problem, but we have to spend some time for identifying that, whether it is a missing data or the real data. We have to do, but with the help of algorithm, we have to do that. We know everything about the data that will be visualized. That is a way of how we are presenting. That is very, very important. That is what I'm saying, that the presentations is very, very important in data visualization. How we are presenting the data, based on that only we can know that whether they are represented about all the data or they are representing about only the particular data. That is based on the data which we are going to visualize. So one thing is we can't visualize all the data with a single presentation. So it will take for each slide will represent something. So based on that, each visualization chart will help us to understand about the data. So single visualization chart is not sufficient to explain all the things. So we need to go for multiple charts for each and every data based on our objective. That is called aim. Does that data visualization tool allow us to export charts in different formats? Yes, all the tools are allowing to export the charts from the different formats. It's a predefined one in all the data visualization tool. Yes, any other query, please? Thank you, madam.
It's my privilege and a great honor to propose the vote of thanks on this occasion. On behalf of Department of Computer Application, I'm extremely thankful to our guest speaker, Dr. Srinivas Perumal, our Associate Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. Sir, your vast knowledge and explanation on data visualization made us to know more about it. Thank you for sharing this knowledge, sir. Thank you all.
Thank you, madam.
We will begin our next section in few minutes. Welcome, sir.
Yeah, thank you. Happy to join with you all. Good morning, everyone.
Good morning, sir. Good morning, sir.
Good morning. We'll wait for some time, madam.
Yes, sir. A few minutes, sir.
Okay.
Now I invite Ms. Sivaranjani N, Assistant Professor, Department of Computer Application, to welcome our guest speaker, Mr. Narayanasamy Kanagasabai.
Yeah, thank you. Thank you, and thanks for warm welcoming. So I am really excited to join with you all. And so because of you guys, actually, I'm able to go through few of the items and then recollect. So it brings a lot of good memory to me as well. So I'm also co-learning with you. So thanks for the opportunity, and I am really grateful. Let us get started, right? So I will share my screen and then I'll get started. Are you guys able to see my screen?
Yes, sir.
Great. So, first of all, welcome for International Virtual Conference for Applied Data Science and Intelligence Computing in 2023. It's really great. I'm happy to be part of it. So, quickly we can jump into it. So, just today's agenda, these are the 4-5 items I'm going to cover. A brief intro on AIML, and then ML development lifecycle, and a brief intro on cloud data engineering, and then recent trends on AIML, and how to build a career in data science. Right? Actually, these are the stuff I wanted to take it. And towards the end, I wanted to spend some time for your queries too. And again, actually, maybe feel free to maybe each and every section. Maybe after completing each and every section, I will just give couple of minutes for questions, doubts, etc. Right? And again, actually, if any pressing need, you can ask questions, or maybe you can type in chat box. Right? Actually, I will follow. So, am I audible? Is it clear, loud and clear? Hello. Can you hear me?
Yes, sir.
Okay, sure. Okay, just give me a minute. Okay. So maybe if you go by AML cases, right? Basically, these are the areas we will generally will work on: data analysis, right? Exploratory data analytics. Probably you will know. We will do the reporting. Suppose if you have the data, assuming we are having data about Tamil Nadu education data, right, for across UGs or across PGs, maybe you can do analysis district wise. How each and every district is performing, what is the lowest score, what is the maximum score, which is performing, which district has good education stuff. All this data we will be able to do, right? So basically the data analysis will be helpful for reporting and dashboard. Quickly understand how the data will be used. Maybe your principal or your team will be interested in your college, but actually district collector will be interested on their district level, and then maybe CM or maybe uh, the chief secretary will be interested on the entire state, right? And if you go for nationwide, actually they will be interested in each and every state. That's how, maybe for an example. And then maybe you all know supervised learning, right? When there is a data available, labeled data available. For example, if you assuming you wanted to predict the housing price, right? If we have data set of 1,000 houses in Vellore, then probably we can do supervised learning, because actually you can predict something whether it's matching or not matching. Accordingly, you can train and get the new data set prices. So that's one use case in supervised learning. That's the regression kind of thing. Or suppose if the house price is this much, how do you get it? Maybe then you can explain. Okay, if it is in prime location, how much it will go? If it is in 2 bedroom, or maybe this is a square feet size, etc. So whenever we have the data, actual data with the values, we can predict and compare. If it is true, if it is matches, maybe we'll be able to predict 90-95% accurate. Generally, if you are predicting with 100% accurate, that's a kind of overfitting, right? When you say overfitting, we are making our algorithm work for particular training set. So this is kind of supervised learning, right? A regression and classification. For example, who will get placed or who will not get placed, right? Actually, we can predict based on the performance, how they are attending the classes, how much is their score, how much their soft skills, etc. If you have the data, we will be able to, suppose based on the previous year's data, you will be able to predict who will get placed or who will not get placed, or who will score, etc. That we can predict. So if you have historical data and if you have the class, then we will be able to do the supervised learning. Unsupervised learning, as you all know, suppose if you have the data set, right? How do we, maybe generally we will bin it, right? Actually, when we go for something called segmentation. So who need more attention, who need more intervention, all these things we can perform by unsupervised learning. When we say there's something called market basket analysis, right? Actually, that's what we call it as unsupervised learning. Then forecasting is nothing but weather prediction, or suppose if particular store in Vellore, how much sales it will incur. Based on that, actually they can have the stock. Suppose if they have more stock, they need more space. If you have less stock, they will lose the value. So maybe store inventory prediction and all, we can do the forecasting, weather prediction, all these things comes under forecasting. Then comes to operational optimization, right? Operational optimization, what we can do was, suppose if there is always we cannot get all the resources, right? Actually, there will be a cost constraint, there will be a time constraint, there will be resource constraint. So we need to optimize. So optimization problems we can do with operation optimization, right? So in the US, one of the doctor actually developed the algorithm, right? That is for kidney transplantation. So kidney, what was happened was, only a particular group of blood kidney will be given to particular patient, right? and there will be a stock. And this data, he did the network analysis, and then he will be able to save 2,000 lives, right? Actually, 2,000 operations successfully done by quickly, because if the particular kidney or liver is not available to transplantation, right? Actually, sometimes the patient will die. So maybe he interconnected all the data, and then he also matches it. And then if the particular organ is available for same region, he will allocate to that person. So by doing that, he got a award, and then he's kind of even recommended for Nobel, but he didn't get Nobel Prize. But he is able to save 2,000 lives and then 2,000 families. Then comes to our deep learning. Deep learning is kind of convolutional neural networks, and then deep neural networks, and then this is also kind of helpful, like how we are learning, right? Actually, as a kid, we started after we born. Actually, we just do the basic activity, then we can just get to know about each and everything, how the fruit looks like, how the car looks like, how the cycle looks like, or how the object looks like, and what is what. The same way we can teach computers something called reinforcement learning, and methodologies available. And even actually, which we'll look into it deeper. It's a kind of neurons, right? Actually, our brain is made up of neurons. So same kind of neurons we can create, and we will be able to connect it. That's part of deep learning. And artificial intelligence and the cognitive AI. So when we come to artificial intelligence, the major difference between we have the actual data stuff started with data mining, right? And then data mining, then data warehousing, data marts came in, right? Actually, then the statistical methods initially, which is separate field, they integrated, machine learning comes in. So supervised learning, unsupervised learning, maybe all the banking use cases with the data points is kind of classical machine learning. And anything what we are doing with the text, right? NLP and video, audio, and images, all this stuff coming under AI. And even your route prediction, right? Actually, Uber or Ola, suppose if you book the cab, actually there is a geospatial search and identifying the route. Not only route, the path, actually they are also calculating the traffic, etc. All these things coming under AI, right? So anything which is data, real-time data integration, and real-time data need to be made, that's kind of called AI. For example, if you want to calculate your credit CIBIL score or something like that, actually that's a kind of classical machine learning. Real-time data feed is not coming there. That's where these are the brief intro on AI, right? So next we will move to so basically why we need to do AML. So basically revenue optimization. So we need to grow our company revenue, right? We need to make our profit more, or we need to minimize the risk, right? Actually, for example, if you look at suppose before giving the loan, actually they are taking the data and then they are calculating some formulas, and then they are whether to give the loan or not, they are deciding, right? Similarly, each and every area we need to minimize the risk, not only loans, etc. Each and every whichever business function, we need to minimize the risk, we need to mitigate the risk. And how do we improve the margin, right? Actually, we need to make it operational efficiency, right? Actually, we need to make it work faster. Suppose if you are going to the restaurant, someone's give the good food, but actually they are taking a lot of time, you will not go, right? So they need to optimize, they need to give the good food, and then they also need to give it quickly, and then it is also cost effective, so at least some extent. So then only we will go for a restaurant, right? Actually, each and every business, they need to do this sort of operational efficiency. And then again improved customer personalized services, right? For example, how good even the product, unless until if there is a need, you will not buy it, right? Sometimes we will buy it if they give some free offers, etc. But generally, if there is no need, we will not buy it. So they need to understand what is our need, what we likes, and then they'll be able to recommend something. So now definitely Google knows better than ourselves. Even whatever you don't know, right? Actually, Google has the data, because actually they are integrating your Facebook data, WhatsApp data, and your LinkedIn, and whatever you are writing, whatever you are searching in Google. All these things they are integrating, and they have the opinion about. They have not the opinion. They have all the facts about. Even sometimes Google has better data than us. Suppose Google knows better than whatever I know better about me. Google knows better than me about me. So that's the kind of objectives. So then, sorry. So if you go for ML development process, right? Actually, these are the areas, whatever infrastructure, maybe the hardware, right? Actually, the VMs, containers, GPUs, right? Actually, the underlying machine, what we need to, suppose if you want to do a train deep learning models, we our PC will not work. We need to have the GPU from either from Google or AWS or Microsoft, and we have to be secured. Whatever data we are doing, we should not maybe data should be accessible only for required people, and personal identity should not be exposed, right? And then we need to have the source artifacts repository. Unlike other application AI ML cases, your data as well as your algorithm, your computer code, all these things will be, whatever data you are training, that is also required, right? Actually, we need to keep this in this one in the repository. Briefly, these are the stuff what we are doing. We need to do the experimentation, right? And then data processing. When you say data processing, we need to get the data from different source, and then we need to do the data cleaning or data wrangling. And after cleaning and wrangling, we need to do the EDA or experimentation. Then we need to do the model training, either whichever algorithm what we are looking for, and then we need to do model evaluation, right? We need to put it in the production, that is model serving, and we need to do the experiments, and then we need to monitor the model. Suppose if you are predicting the model, if you are developing the model, and then if you are making it in production, right? If it is not performing well, right, then we need to just to do the corrections. And then how the data will flow. For example, you are applying the application, right? Very simple. If you can take, if you book Ola or Uber, how many interfaces we are getting? Because once you just choose the source location, target location, the data is sent to the server, and then they will search for nearest location drivers availability, and whomsoever free they will get assigned. Okay, once we assign the data, they will calculate the distance, they will put the price, right? And then this data they search, they will assign. Once they accept, then the person will reach. We will also choose the method. Then we'll get the alert. Similarly, there is a lot of calls going between in and there. Similarly, suppose if you make credit card transaction, right? Maybe about which is once you are sweeping in the POS machine, it is going to your maybe the machine, whatever. Suppose your card may be from HDFC, and the machine POS machine in the shop will be Axis Bank. So from Axis Bank server to it will go to the HDFC Bank server. The money will be taken, and then which will go to the maybe their POS machine, which needs to be settled on Axis Bank, right? Actually, then there is an intermediary. All these calls will happen in a couple of seconds. All the things are getting settled down. So similarly, suppose why we are quoting this example. For example, if it is anomaly detection. For example, every day, every now and then I used to make 5,000, 10,000 kind of transactions. Suppose if I make 1 lakh, 1.5 lakh, it's a kind of anomaly. So generally, this person years together made only 10,000 rupees as a transaction. Now he is making 1 lakh. Then they will catch it. Then they will not approve the transaction, and they will call and confirm. Then only they will approve. So this thing should be captured immediately, right? So similarly, each and many cases, actually, if there is a variation from what we are doing, right, actually that will need to be captured. So suppose if they are not able to capture it, there will be money loss. Suppose some malpractice happens. Sometimes even it's a real transaction also possible, but actually some malpractice happens, it's a problem. So why we are giving this was, generally people will have a perception of machine learning is nothing but developing the model, maybe developing some algorithm and getting 95% accuracy, right? But actually that won't work that way. So we need to get the data from different sources, and we need to do the proper EDA, and then we need to do the massive value analysis, and we need to impute the data. Suppose if the data is not clear, right? For example, if anybody in your college data, if the date of birth is sometime 75 or 65 or 1955, that's the wrong data, right? Maybe accept the professor's data. So students' data should be within 20-25 years. Suppose anything beyond 25, maybe anything less than 15 is kind of not valid data. We can make out that way, right? Or some person's age beyond 100 years, we need to check. Or suppose your scores are missing, or your date of birth is missing, or maybe any other critical data is missing. So if the data is missing, we cannot make out anything, right? So either we need to remove the data, or we need to just to find out average. So if there is a number, it's when you can find out average age or something like that. Or maybe we need to go back and then get the actual data, then include in the algorithm. So data cleaning, data quality is very, very important. So that's where actually this data processing is, right, very, very important. And suppose if you have large volume data, we need to write efficient algorithms. So basically what we need to do was how to get the data from Excel, how CSV file, text file, image file, etc. Right, and then how to do the exploratory analysis, how to clean the data, and how to understand the data. So all these things we need to do, and then we need to understand what is the business problem we are working on. So based on that, actually we need to make out, and then we need to go for it. So if you look at, these are the stuff: ML development, ML training, operationalization, continuous training, continuous deployment, model deployment. This is kind of ML model putting into production, continuous monitoring. If there is any problem, we need to do the again development, and then the whole cycle continues. This is how ML model works. So mostly in the academic area, you will be put into only the ML development, right? And all this area probably we might not know, you might not use it, but actually you need to have the understanding of it. So algorithm development is kind of only 30-40%, right? And remaining stuff, we need to be best at all the activity. Then only your whatever model you are developing will be go to the production. So ML is kind of data engineering, ML engineering, and app engineering. What is data engineering? Actually, the maybe data warehouse or data lake, or maybe how to store the data, how to retrieve the data. Your source can be plot file or CSV file or database, etc. Right? Actually, we need to define that. And then ML engineering, your algorithm development, whether classification, regression, or whatever, that comes under ML engineering. Then app engineering is nothing but your CI/CD, right? CI/CD is nothing but continuous integration, continuous deployment, right? You guys are heard of Kubernetes? Anyone say yes or no? Hello. Okay. So maybe understand what is DevOps, right? Actually, that is also, you don't need to be expert in DevOps, but you need to understand what is DevOps. So because actually that will make you for getting into the industry, or maybe doing the bigger processes. Okay. So again, this is a ML development, coding and configuration, and then maybe whatever model you developed, you need to put into production, right? And then maybe we need to continuously train, and you need to deploy the model, and you need to do the stuff. You need to do the, suppose, for example, if your loan application, all the data feeds in, maybe you need to give the output whether particular person is eligible for getting the loan or not getting the loan. Something called CIBIL score or maybe credit score, etc., will coming in, and then continuous monitoring. This is a kind of end-to-end workflow in the ML life cycle. So again, actually, these are the data sets. Your student data set, right, and maybe loan data set, employee data set, or loan applicant data set. So first thing is actually what we need to do was, maybe while you are doing academic, maybe you can do regression. So you can do classification, you can do forecasting, you can do NLP or whatever. But when it comes to business, we should not work. If I have the solution, I can go. We need to define the problem, right? Actually, then only we'll be able to give the right solution. We need to define the problem. What is the business problem to solve? So when we solve the problem, right, we need to think whether the problem is real, right? Is it worth solving, right? And shall we win, right? We'll call it as a framework. Is it real? Is it worth solving? Shall we win? So that's how the business startups will work. Actually, suppose if you are choosing some problem, right? Whether the problem is worth solving. That means actually whether already solutions, lot of solutions available, economically available, then you don't need to go and solve it unless until if you are giving some effectiveness. So we need to think whether is it a real problem to be solved? If it is a real problem, fine. Is it worth to solve? And even if it is worth to solve, if we solve, we will be able to win, right? For example, we are in LMS space, right? Actually, suppose if we are taking some of the use cases, right? Actually, first of all, I need to understand whether it's a real problem and is worth solving. It will bring revenue to my organization. So then only I will solve it. Because if I take any problem, they will not approve it. They will not give the effort. They will not give the allocation, etc. So basically, even real life, you can apply this formula. Whether it's real, is it worth to solve, and if you solve, you will be able to win. Data selection, right? Data exploration. So future engineering, model development, model validation. So future engineering is nothing but, for example, if date of birth is given, right, you can calculate the age. You can use age as one of the future. Suppose your scores are given, you can take out averages. You can take out maybe compare your quarterly score, first semester score, second semester score, etc. And you can maybe you can generate more futures, right? So future is nothing but this future is nothing but, suppose if you have individual field, from that fields you will get additional information. So that's a kind of deriving it, right? So why the future engineering is very, very important was, suppose if you use the data, if you give it to a deep learning model, it will build complex algorithms with simplified data. Suppose if you are having more detailed data, you are work on the futures, then your algorithm turned to be very simple and very straightforward. So that's where future engineering comes in, right? So then actually we need to have the models. Suppose if you are developing 10-20 models, we need to put it in the registry, we need to compare it. Similarly, we need to have the trained data and we need to have the versioning and all. So that's how the ML development process comes into place. Okay, so now, okay, here any doubts so far?
No, sir. It's clear.
Okay. So, is it useful?
Yes, sir.
Okay, thank you. So I wanted to briefly touch upon the AWS data pipeline, data engineering side, right? When we take out any data, maybe this will be additional skills, right? Some of I guess actually you guys are from UG, PG, and then maybe some of the research scholars available. And I will give the industry perspective here. Suppose someone goes to the social media companies like LinkedIn, Facebook, and maybe AWS, Google, etc., or any company which is working with marketing, etc. They will be doing a lot of machine learning stuff, right? A lot of analytics, a lot of machine learning they will be doing. When we go for banking and other areas, still they're considering machine learning and data engineering, all the teams together, right? So, but actually, even then, just to give that to briefly understand what is going on, right? Your data may be coming from IoT devices, right? Maybe factory data will come or any data will come. So we have something called Kinesis streams, right? There we can send thousands of data. 1,000 data, or maybe whatever, that's a batch, right? Some batch is nothing but a bulk data is monthly salary processing, right? Actually, that's a batch processing. So we can send as a batch. So something called Kinesis streams works for real-time data, right? There is something called the Kinesis batch, right? Actually, that's working for batch data. Sorry, the Firehouse is kind of sending the near real-time data. Kinesis streams is real-time data. Whatever data, suppose if you key in something, if you make a call in the Uber or Facebook, Uber or something, it is getting posted immediately, right? Same kind of stuff. The real-time data will be going through Kinesis streams. Okay, something is not important, you can send it later. That will go through Kinesis Firehouse, right? And other things, actually, we can make it as a file transfer. We don't need to go for Kinesis batch. Actually, we can move the file and then we can send out a notification. They will pick up, right? Actually, that's how the batch processing will work. Okay, so this is ingesting the data from one, for example, from one place to one database to other database, or one organization to other organization. We need to do. Okay, and why? Because suppose if you have college information system, right? Actually, that's an OLTP system. So we cannot do the reporting dashboard on OLTP system. So we need to have the data warehouse, or we need to have some data lake, etc. So first of all, data is going to S3 and Glacier, right? And that's a kind of data lake. So what we can do was, we have something called Elastic MapReduce. It's nothing but Hadoop ecosystem on the AWS, and Kinesis Analytics, which will do the operations and which will collate the data. There is something called Glue ETL, pick up the data and then move it here, right? SageMaker it's like an IBM Watson, right? Actually, which is a kind of machine learning engine which is provided. You can use any one of these services. Not necessarily we need to use all the services, depending upon the need. And these are the databases available, right? We have Amazon Redshift. RDS nothing but RDS is a database, right? Actually, which is remote database system, which is kind of either Oracle or relational database services, which is kind of used for Oracle or DB2 or SQL Server. If you want to use it within Amazon, then you can use RDS services. And there is something called DynamoDB, right? And then Kinesis Streams, Glue Catalog. So this is a data warehouse. And we have something called Data SageMaker Studio. We can do the Python notebook or Scala notebook, etc. And something called Quick Insights available, which is using for you are doing the dashboards, right? Here you can use Tableau or Power BI, right? Or ClickView. There is a lot of these are the BI tools. Presentation layer is nothing but we can do dashboard or report, or so this is kind of, this whole pipeline is coming under data engineering, till SageMaker, till the data warehouse. And this area which is coming under presentation is coming under data visualization. Some of the organization they are hiring data visualization experts, and this area comes under data engineer, right? Data engineering or data warehouse engineer or something similar. So to food for thought, you need to understand what is streaming or what is real-time processing and what is batch processing. And Lambda function is nothing but serverless, right? If you want to perform some function, you don't need to call VM or any machine. There is a function which you can write it either in Python or Scala, and you can do this stuff, right? So this is what AWS data pipeline, right? Similarly, same thing applies. Instead of Kinesis, we have Event Hub, right? IoT Hub is nothing but IoT data, receiving the IoT data from Event Hub. And then instead of storage, S3, right? S3 is simple storage service, right? That's what S3 in Amazon. Here we have data lake store. So we have Steam Analytics, Azure ML, or Snaps Analytics, and Data Factory for scheduling, right? This is a preparation and presentation layer. Either we can store it in Azure SQL, data catalog, or Event Hub. From Event Hub, we can transform to other layers. And Redis cache is in-memory cache. And this is what actually used for Designer Studio and Power BI. Again, you can use your own tool like Tableau or ClickView, etc. Right? And you can get it, and you can use. So this is how you need to understand what is ingestion. But actually, if you go for any cloud, these are all standards. What is ingestion layer? What is data lake? And what is presentation layer? What is data warehouse? And then what is presentation or BI layer? Right? Data visualization layer. This is on the Azure data line, right? And when we come to Google, there is something called instead of Lambda function, right? Azure function, actually here cloud functions, cloud IoT. PubSub is a layer. Here batch and real time done in PubSub itself. So the storage called Google Storage, and here this batch operation comes under data proc, and then the streaming operation comes under, that is the real-time data movement comes under data flow, right? Big table is nothing but your HBase, right? Hadoop layer. BigQuery is you can relate to Oracle or DB2 SQL Server. So again, from here, data lab and data studio cloud function goes on. And I think you guys might use Google Colabs, right? Colabs notebooks, which is freely available. You can use it. You can do, instead of installing your own Python notebook, actually you can use Google Colab, and then you can get it for free. You can run algorithm already available, and you can also use your algorithm and then store it. So this is on the GCP pipeline. So fine. So any questions on this data pipeline? Maybe it is too much, but what you can do was actually you can go through once. Maybe I'll share the presentation. You guys can go through and try to understand high level what is ingestion, what is data lake, and what is preparation, and at least high level, so that this will be helpful to understand the business perspective. Why we need to build data engineering, data pipeline? For example, I will give you the very, very important concept here, right? Anybody knows what is API? Okay, so application programming interface, right? Earlier, suppose they build point-to-point connection. For example, if I need to send the data to Auxilium College, actually maybe I will develop a mod. I will just understand the structure. I will send the data. We will have the agreement. We'll share the data and then go. But what happens was then mostly it was tightly coupled. Both of us needs to use same language. Either if I am using Java, you also need to use Java, tightly coupled system. But that will not work in real life use cases. What if I need to send the data for all the colleges, right? Maybe suppose I'm a centralized body, I will write API, right? And then I will put it in the endpoint. For example, get the results. Assuming actually we are writing a service, for sharing the result. Assuming as a simple, what we can give was, okay, which year and which degree, which semester, etc. That will be the request. Then I will process that query and then I will post the response back. And here advantage is, you maybe Auxilium college and I don't want to be in the same language or same server, etc. You can hit my server, get the data, and then push it. That's how Uber or any services which they will be integrated with multiple services. So that's, see, all the revolution happens because of cloud, API, mobile, and all the stuff. Because mobile is helping us to do the personal advertisements, personal campaigns, or maybe understanding the data, who is, because actually they know how much we are earning, how what we like, what we don't like, and then how to at what time they need to send the ad, etc. Suppose if I search something, right, actually I'll get related. Suppose if I search for some dresses, I will get a lot of ads from different companies, right? Actually, so that's how actually they are just making a money. So here, cloud, suppose all these things, whatever we are doing, right? Actually, now I will be able to set the data warehouse within 1 day. But earlier days, I need to set up maybe 20 years back. So if I want to set the data warehouse, I need to procure the machine. Sometimes it will take a year, right? And 6 months, because actually some of the servers will not be available, which has happened actually, because actually some of the production delayed because server provisioning is not happening. And but now, if you have money, right? For example, I used to analyze this large volume data set from NIC and BSc, right? Actually, billions of rows, right? Actually, that cost only $50, right? So, but actually, if I need to $50 for 3 months, so I am able to complete with whatever the free credits are given. Only thing, you need to have the credit card. You need to get the get Google trial or AWS trial or Azure trial, right? Actually, you can use machine learning services. So this is what it is. So life made very easy because of the cloud, and then this API, right? Earlier, what I mentioned was, so please understand how to write the API, right? Even you are a machine learning engineer, you need to know how to write the API, right? Now it's easy. You have maybe in our I just studied 30 years back. I need to go to library and then I need to get the Xerox, and maybe at the time internet was not there. And then maybe after, maybe at the time only the browsing center, it's very crowded. And then the bandwidth, if you make a search, maybe sending 1 or 2 mails or making 1 or 2 search itself will take half an hour, 1 hour. So we will not be able to pay. So generally we used to go to libraries and then we need to get Xeroxes, or maybe sometimes student Xerox. But now your challenge was, you have plenty of material, right? So unless until if you are not focusing, you will get into a lot of trouble. Maybe you'll get plenty of material and then you will search for a lot, but actually you will not get anything. So that's how too much information is also a big challenge. So actually this is a comparison. We have classification, regression, anomaly detection, recommendations. What is recommendation? Suppose if you are buying some books, right? Actually, then maybe if you get this book, maybe somebody getting this book also. Whomsoever purchasing this book is doing this, right? And then something called data labeling, right? Actually, data labeling. Actually, suppose if there is an image, we need to do the data labeling. So these are the steps which is supported. I will share the PPT. Maybe you can go through. But there are one point to note, there are about 10 to 15 regression methods available. At least you need to do all the regression, and then maybe a classification, we need to go for different algorithms, right? And all of the stuff. Maybe you need to put your hands dirty and you need to use it. You need to, unless until if you are not coding, and then if you are not seeing the problem, analyzing it, so it will not be very difficult. So you need to use PyCaret or scikit-learn library if you are using Python, right? Actually, similarly, there is a lot of algorithms available, but still you need to stick to some packages. You need to go for it. So before moving into latest technology like TensorFlow or maybe etc., you need to get the other stuff is done. the basics getting done. So here we have the speech recognition, right? Text to speech, entity extraction. What is entity? Maybe the named entities like organization name, country name, person name. So key phrase extraction is available, and language recognition. So all these services, they will be able to, suppose if you pause Chinese language, they will be able to give English translation or Tamil translation, whatever. So language recognizing and then translation. Topics extraction. So it will extract the topics, which will do the spell check. Maybe Microsoft alone having the spell check, remaining don't have. Auto completion, voice verification, right? Suppose if I am speaking, maybe after some time, voice we can verify same voice or different voice. What is intention analysis? So what kind of intention we are having, that we can do. So we can extract the metadata. We can find out relationship analysis, sentiment analysis. So when you write the review, whether positive, negative, or maybe mixed, etc., right? When you can do the personality analysis. So filtering inappropriate content, obscene pictures, all these things we can filter out. And low quality audio handling, low image handling. Similarly, when we take image, object detection, scene detection, face detection. So face recognition, matching the face, right? For example, Aadhaar face, your face is matching or not. Actually, all these things we can do, right? For example, if you want to do the instant loan approval, you can get Aadhaar or maybe driving license or maybe the PAN card or any identity. They can compare and do that stuff. They can do the facial analysis in the photo. So inappropriate content detection, celebrity recognition. See, suppose if it's a cricketer or maybe a celebrity, they will be able to find out in the larger crowd. Suppose in the picture, if there is a text, we can recognize that. If it is handwritten text or not, we can recognize. Logo detection is there, landmark detection is there. Whether in the image food was there or not. So AWS has some services. Homework for you was search for speech and text processing. You will get all these APIs. Search for image analysis API. You can get all this API. You can use. You can send the input. Even they will be giving the sample. Just that you need to search and use it, right? So all these things are actually there is API available. So similarly, the same thing available for video. Same whatever available in the even we can do the search in the videos. Okay. Okay. Any questions? Okay, so I will take another 10 minutes, then I will open for some questions. This I wanted to just quickly give the overview, right? Democratized. See, these are the three aspects we need to do. Democratized, dynamic, and data centric. What is democratic? We need to bring more people, right, to AI, and then suppose if the team of 50 people are there, whatever the data, whatever tools they need, actually that should be easily accessible, right? And we need to use the data, leverage it. So earlier, whatever I covered, right? Data, apps, ML apps, model apps, and DevOps. These three disciplines put together, maybe either you can come here as a data ops engineer or ML ops engineer or DevOps engineer or pure machine learning engineer. So maybe earlier days, why I'm saying this was earlier days, people used to choose, at least now it's a lot of things have changed. Earlier people used to choose only doctor, engineering, and maybe agri profession. Most of them, 80%, 90%, remaining only go for business or maybe any other alternate professions. Now people are widespread, right? Even IT, within this, mostly don't think only ML engineering or AI engineering alone. So maybe the data engineering also good visibility and good roles available. DevOps, and then full stack developer, right? See, now maybe you need to understand what is full stack developer. Earlier, because industry is changing rapidly. Earlier, they look for one person doing all. Then they went for database engineer, front-end engineer, back-end engineer, UI engineer, etc., etc. Now, at least if we divide that way 4 or 5 areas, there is some gray areas. That's why now they come up with the full stack engineer. One person itself will be able to do, at least half of the team should be full stack. When they say full stack, actually they will be well versed in database, they will be well versed in front end, back end, middleware, and deployment, so that actually the operation will be faster. So if you have good aptitude, and then if you want to take more challenging role, you can try for full stack, right? If you want mathematical savvy, you can go for data engineering. If you like write queries, if you do analysis, then you can go for data analysis. So what you need to do was, instead of choosing this career has a lot of opportunity, better you need to choose what you are good at, what you like most, and what you can do interestingly, right? What your passion says. If you follow your passion, actually you can do wonders, right? So basically these are the tools, right? Actually, if you go for AI engineering, there is something called weights and biases, Spell, ActoML, Aris AI, Data Robot, Kenim, and Azure. Maybe here there are services you need to go for, but actually other products they will do. This will whatever the full life cycle what I covered, right? Actually that will be covered any one of these tools, ActoML or weights and biases, Data Robot, etc. The good news is you can get the trial, right? So similarly, this is how we need to do: add use case, process the data, create the model, explain the model. Okay, another important aspect was explain the model. For example, if you develop fantastic algorithm, right? Maybe if you go to your professor or if you go to your manager, the first thing what they will ask was, please explain me why you are getting what you are getting. So as long as you are able to explain, right? Actually, because business people will look for that. So as long as we are able to explain, and then only they will be buying it. Even if it is accurate, we are not able to explain how it comes, right? Actually, that will be a problem. That's why maybe you all aware of it. You would have been watched Ramanujan's movie. There is a dialogue. Actually, maybe 2 interesting dialogues was there. Professor Hardy and then some of the mathematical professors will go through the Ramanujan's notebook, and then they will say, to complete this notebook, we need 1 life. Then Ramanujan will say, I have 2 more notebooks. He had 3 notebooks. The mathematical world famous professor itself, he will say, to go through the entire notebook, actually I need a one life. Then he will say, and I have another 2 notebooks. So similarly, after going through all, the problem with Ramanujan was actually he used to have the problem and then he will write only solution. But actually to get mathematically approved or mathematical council, etc., the problem needs to be explained. What is the problem and how you solved it? What is the solution? Then only it will be approved. So that is applicable to even machine learning world also, right? So we need to explain the model. Suppose we are getting some output, how you are getting it, why you are getting it, that needs to be explained. So we have something called H2OA, data IQ. So H2OA you can try. Suppose for example, if you are trying this one of the regression problem, they will run 10 models. Each and every regression type, different types of regression. What is the accuracy? What is the root mean square error, etc., etc. They will give it to you, right? And you can choose the best algorithm. So maybe you can use any one of these tools, right? So earlier, otherwise we need to write all the algorithms and we need to try each and everything. See, now you have very good infrastructure, right? Very good hardware. Because actually when I studied college, right? Actually we have 8-inch floppy and then 5.25-inch floppy, etc. That is about 1.2 MB. Even a hard disk size is only 20 MB. Now think about the mobile, right? So in our era, actually while we started, luckily I born slightly later, but actually others, they got it, punched cards, etc. So you guys are living in the very good time. A lot of resources, and only challenge you guys actually you have abundance, too much of resources. Only thing you need to choose wise, and then you need to move on, right? So responsible AI, right? Actually, the value, trust, human centricness, fairness, say explainability, and then accountability, compliance, safety, right? So all the things, see, we have to be, suppose if we get data, we should not go to outside the world, right? And then we need to keep the personally identifiable information, right? There are GDPR regulation, there are data privacy regulations are there. And we need to have the human centricity. So these are the responsible AI tooling. So we have Fiddler and DreamQuark, True Era. These are the tool available, right? To mitigate, to stay, to have the data privacy, etc. These are the tools available. And dynamism, right? Actually, so another important aspect was now the data coming from the factory, right? Remote locations. There, if you don't have any, then that's why the edge computing is coming in. Maybe think about sending the train data, right? Flight data, or any other factory data which is in the marine, etc. Right? Actually, this edge computing is coming in. Algorithm, direct devices, etc. is this is kind of same thing, but actually this edge computing is a new thing which is evolving. There is something called TinyML, Zip, Baidu, cloud providers are there, and then BrainCube is a software, CocoaPy, DeepLight. So interesting thing was actually you can take and then do some research. At least go through one or two tools. Even you don't need to get deeper into it, because why, which is important was in our time, actually the changes will happen 1 or 2 years once. Now within a month, right? Actually, a lot of things are going outdated. So good news is actually if we are strong in basics and fundamental, if we are able to adapt, we don't need to worry about it, right? I started my career with Foxtrot, COBOL, etc. I never know cloud will come, mobile, this kind of stuff will come. But actually, as much as possible, I try to cope up, advise it. So another thing is actually we should not look at only AI, right? Actually, we need to simulation, machine learning, natural language processing, graphs, logical rules. So we need to do composite. So we don't need to force fit AI ML alone. We need to use RPA or augmented reality, etc. If there is a need, if there is an only one and only need. So that's a kind something called composite AI. That's why you can give the comprehensive solutions. So these are the technologies available: Indigo Data, Petum, and Exponential AI, Black Swan technologies. You can use it. And then transformers, you can think of ChatGPT, Hugging Faces, right? These are the stuff coming in, which will generate, even actually if you give some description, now we will be able to get the image, right? And similarly, text generation outputs are there, and chatbots, right? Maybe mostly the call center compute, maybe virtual agents replacing in the human. And now as much as possible, it is also giving the context based one, like a human, right? For example, if you and me as a friend, maybe when you call, maybe we can start from the previous conversation, right? So that's how even the same context aware communication coming on the stuff. So maybe we need to improve the quality, mitigate the bias, right? What is a bias? Maybe understand something in some different way, maybe so, and then augmented, maybe enriching the data. So we need to look at all the confidence, right? Actually, confidentially we need to maintain, right? These are the ethics part of it we need to do. And again, actually, this data augmentation, data resampling, right? Suppose sometime we are doing something, right? Data will be skewed. What do you mean by skewed? Suppose if we have 99% one data group and 1% another data group, we have 1% samples are not good, right? Actually, that is not enough. So we need to do oversampling or undersampling, some sort of, or we need to generate some data, right? Actually, so we need to create even synthetic data. Suppose if you're not able to get some real data, maybe you need to create data and then you need to use it, right? When real data is, that's what actually we can do. These are the these are the vendors providing the synthetic data. So future stores. See, for example, we have the machine learning pipeline where the data originated and how it is processed, and then all these things, something called lineage. We'll transform the data. We'll do the future engineering or future selection. We can transform how it is transformed. Suppose if you are taking one particular case is a problem, right? We need to trace back. So this is called future stores or future engineering. Actually, we need to do the versioning, monitor, serve, understand all these things comes under this future stores. So these are the technologies available for future stores, right? H2 AI feature store and Google Vertex AI feature store, Cascada, Molecule, Spin Machine, Tecton, right? Feast. So these are the feature stores. And what is federated learning? Suppose if different companies are working, either they can share the same features, different samples, right? For example, if a college information system shares, actually Auxilium shares some data, right? They can share the same feature, but actually not entire sample. Maybe they can give some set of maybe 10% data to one particular college, or maybe another 10% for different colleges, right? And maybe they can another way is we can share the same sample with the different features, maybe different data points, not all the data points to all, right? So with this, actually we will be able to share and why this is important was, suppose if we share the data, our competitor will take our business away. So we cannot give it outside the world. But actually, if we are not giving out, we cannot get anything. So we need to strike a balance. So we need to find out the way, right? So either this is how we can share. Suppose if 1,000 students are there, maybe 50 students sample you can share with one college. Same sample, same features, different sample. Maybe you can share to 10 different colleges. And similarly, you can share the same sample, but actually maybe different features for different companies. So that's a kind of federated learning. So these are the tools available for doing the federated learning. And another interesting symbol, this is a graph data science. So we can integrate news, weather, social event, etc. And then we can integrate multiple sources, and then we can build the relationships, similarities, cohorts, community, etc. That's how the world is going on, right? So these are the brief cap, right? AI engineering new roles, recipes and blueprints, responsible AI tooling, edge AI, composite AI, transformers, and then synthetic data, future stores, and federated learning, right? And graph data science. So okay. Any questions? Okay. So maybe I will just I will give you a brief another 5 minutes. Actually, I will just to build the career. What is required, right? Definitely, writing a good SQL is a must, because we need to get the data from databases, and then we need to write. We need to do the analysis, all the stuff. So basically, writing a SQL is good skill, and then basic understanding on statistics and linear algebra. At least even not depth knowledge, but at least you need to know what is the basics, right? So and the statistics knowledge is very important, and good. Maybe you need to good at any one language, Python or R, Scala. Python and R, Scala is similar. Either you can use R or Python, right? Get well versed. That's my advice. But some of them interested have time pick up two. But actually you need to be expert at least in one. If you are learning both, it's fine. But actually you need to be expert at one. Definitely that's important. And domain knowledge is important, right? For example, if you are doing basic machine, that's a very important thing. Actually, wherever you go, the business knowledge or function, whichever domain you are working, right? Actually, you need to do the research. So you should not be the very fully technical person, right? You cannot maximize the output. So you need to know, you need to understand the business. You need to understand. You need to make a study. you need to discuss with the industry experts on the particular domain. And then we need to do the business, how to solve the business, how to frame the business problem to solve, right? Identifying the business problem. So next important thing is agile, right? What is agile? So maybe we are all we have a lot of stuff, actually, video, mobile, right, TV, and WhatsApp, etc. So focusing, right, actually committing what we are going to do for a given day, and then accomplishing that, right? Maybe for setting a target for a month and breaking into daily basis, and then attaining that. That's what actually really important. Otherwise, a lot of folks are interested in new recent technology things, right? Recent tools will not help unless until if you don't know the basics, and if you are not doing the real practice, right? You cannot. Maybe that's what agile is important. Agile is nothing but living in the moment, right, and committing for the day. Whatever, suppose if I am next five today I am going to 4 hours, I am going to perform some exercise, regular exercise. I need to commit it. I need to perform it. I will start. It will be interesting. Some other. I will search something. I will go to something. Then I'll forget this. After 15 days, I will come back. That won't work, right? So maybe if you are being agile is nothing but focusing on what is important and committing to it. And design thinking, right? Design thinking is analyzing the problem step by step, understanding the importance, and doing all the stuff, right? So innovation is nothing but actually how to maximize it, or how to find out the value out of it, right? We are solving the problem, but actually how to get the value out of it. And we need to have the strategic thinking, and we need to maximize our output. We need to meet our objective, basically. So then only we can able to do. And you have to you need to create, suppose if you are not having Git profile, please create a Git profile. Whatever algorithms, procedures, etc. you are training. Now currently industry is looking for Git profile and mini hackathon, maybe medium post, right? Or any blogs on the data science, whichever field. That is really important. Maybe whatever you are writing in college article, right? All these things will be helpful. So we need to build a Git profile. If already you guys are not, GitHub is free. Whatever algorithms, whatever material you are gathering, you might have it in your folder. Instead, actually put it in the GitHub, share it so that actually you can get it. Maybe form a small group, right? Don't do practice individually. So form a small 3 or 4 like-minded people, and having different somebody good at data engineering, somebody good at application programming, somebody good at math, somebody good at some particular domain. Maybe you guys can form a group and then develop the algorithm. I think that will be helpful. So please build GitHub profile if you are not already built, right? That's really important, right? And then try to understand what is API and whatever I started, right? Actually, this cloud data engineering. Maybe do just Google search it and try to understand. So more than anything, along with this, another important thing, soft skills. How to, whatever you are speaking, right? You should be able to put it in writing also, right? Good documentation skill, good communication skill, good negotiation skills, right? And most importantly, what I thought of not giving any advice, but still I'm going for one small advice. Carl Lewis is a kind of world famous Olympic winner. They asked, how do you identify the particular children will be good for sports or not, whether they can choose the for sports career or not. Then he said, actually, okay, if till 10 to 12 years, everyone interested in playing, right? Any game, we will be interested to playing. Any fun, we will do it. But after some time, maybe after knowing the game fully, most of them will lose the interest. They will not go. But if you want to build the career in the sports, what he is saying was actually each and every day you need to go and practice and we need to improve and get to the mastery, right? Even if you are always asked to go over in the night, actually you should be able to perform the activity, whatever in the game, running or whatever activity he performing, he'll be able to perform it at the highest level, like Messi did, Sachin did, Kohli did, and maybe MSD did, all the way. Same thing applies for data science also. It's kind of long-term commitment, and you need to be each and every, you need to be patient, and you need to be built one by one, and then you need to work really hard. But it's doable. That's the interesting stuff. Only thing, initially it will be more exciting. Then you may get frustrated because if you are not getting the result, and then maybe sometimes even challenging. But yeah, that's how the learning happens, right? Actually, if you want to learn cycling, right? Actually, without falling, we cannot learn cycling, right? That's the difficult part. But if you are very conscious about not falling, and you will not learn, right? Actually, maybe smooth sea will not make a good mariner, right? So, as if you are not getting frustrated, you are not tried enough. That's how I used to think. So, work hard and work smarter, and practice, right? So, yeah, with that, actually, I'm done. So maybe if any questions, I can take it. One minute.
Sir, in chat box, participants have asked questions, sir.
Okay. Sorry, actually, I think maybe since I'm screen sharing, actually, I'm not able to answer it. Sorry for that. Okay, so
can I read it out, sir?
No, actually, I will go one by one. And Priyadarshini asked, what is data wrangling, right?
Yes.
Data wrangling is kind of, they will call it as a data massaging, or maybe we need to do the data cleaning first, right? For example, like I said, right? Suppose you are assuming your academic scores, maybe your academic profile. It should have date of birth, which year you are in, and which semester, what is the score, etc. Suppose if the 10 students, the year of study is not there, another 10 students date of birth is not there, some of the students data and the scoring is not there, what do you will do with the data set? So we need to find out the missing values, but actually we cannot fill all the values, right? Because we cannot put the random date of birth. So we need, suppose if the date of birth we are using, suppose we are not using date of birth future, we can move on. But if we are using date of birth future, we need to get the data. So when we say data wrangling, right? So maybe cleaning this data, maybe making some missing value analysis. Some cases we can make out average, or maybe maximum occurrence value we can put it. And again, we can also create a feature. So all these things comes under data wrangling, right? So good question. So data wrangling is, maybe you can also Google it, and then you can also get more information on that. Okay, so what are the common issues in ML, and how can Bhumika? That's a really interesting question. Thanks for asking. So first thing is, whatever we do, right? Explainability, right? So first thing is explainability. Actually, that's really important, because actually we need to we need to just put out whatever algorithm we are developing. Some cases we may deep learning model that we cannot explain, so that's slightly a challenging one, right? So now there are algorithms coming. SHAP, AWS SHAP is there. So there are some explainability algorithms are available. We can do that. Another thing is data privacy, right? Data privacy is kind of data privacy and compliance. Suppose if any personal and individual data, which we need to protect it, we need to store it in secured places. And always the most important thing is bias, right? By watching them, actually we will have opinion about somebody, right? We may or may not be right? Actually, but similarly, we will have some preconceived notions. And even data is also having that biases, right? Actually, we need to identify and remove the biases, right? And that's one thing. Another thing is too much focus on the algorithm alone, because actually whatever I explained, right? Actually, maybe there are about 10-20 steps. We need to perform all the steps. Algorithm, of course, are really important, right? It's like a heart and brain, or heart or brain, actually, maybe. But actually, we need to the body to perform. We need to have good leg, hands. Our digestion system should be perfect. Then only we will be complete human, right? So with the brain and heart alone, we cannot live. But okay, if remaining all other functions are performing, but actually that's now heart is not performing, then that's also a challenge, right? So that's how it's going on, Bhumika. So, and then big table. So big table is kind of like Hadoop, right? Big data Hadoop ecosystem. Google's database data lake is nothing but big table. So we have something called BigQuery. BigQuery is like Oracle SQL Server, DB2. Bigtable is nothing but like Amazon EMR, Elastic MapReduce. Amazon calls Elastic MapReduce. That way here GCP is a big one. Okay, Kritika, actually that's which is better to study data science or AI. Okay, so here we cannot go straight away to AI, right? Actually, because we either go for data science or machine learning, etc. We need to have the statistics skills, some amount of programming skills, and you need to learn basics of data science or ML. Then only you will be able to move to AI. But AI is kind of really, if you are kind of fascinated about image processing and video analysis and maybe or chatbot technologies, etc., then AI is a good option. But actually, you need to work hard and then you need to get it. But it's like going for maybe kind of BSc or MSc, right? But actually, no other option. You have to go undergraduate, then only you can go to PG. But actually, you can specialize on AI, right? So AI has, because actually the AI has a lot of future, and then maybe because a lot of new things are coming on, and maybe you can get there. A lot of algorithms now simplified. See, 10 years back, whatever we did for months. Now we will be able to do it in days because of tooling, right? That's how maybe maybe 10-15 years later, AI will be a core subject in degree in +2 level itself. So because nobody will go and study separately, so that's how it's going on. So good, Amali. Actually, that's a real interesting question. You can write it in Python, right? And interesting thing was API is not very big deal, right? Only signature is different. See, when you write a procedure, C procedure or function, right? The signature changes. Similarly, API we need there is a different signature, right? Actually, what is the input, and then maybe where it get hosted, maybe sending the data back. So you can write a Python API or Java API, right? And etc. That's where you can use PyCaret. You can set up, and then you can use PyCaret. Simply, it will give the API. It will give any algorithm. If you develop, you can get an API, and then you can get it processed. There is a lot of tools available. You can also go to Coursera, and then you can look at any of the Google courses, right? Especially AML engineering side, you can use that stuff. You use that API building, and there are good books around. Okay, so what is overfitting, right? Overfitting is kind of like I mentioned, right? Actually, for example, whenever we develop the algorithm, we can get 80% accuracy. By tuning something, we'll get 95%. And maybe making the algorithm exactly working for the sample, that's kind of overfitting, right? So that is actually customizing the API, customizing the ML algorithm to the particular data set. That is what called overfitting. Overfitting is nothing but making the data work, making the data prediction or data classification work for all the cases by tweaking algorithm, or maybe customizing to that. The algorithm should be general, right? For example, maybe there will be some rule of thumb. Actually, maybe if you are developing algorithm, maybe see in general anything above 80% accuracy is good. So, for example, today if it is rains or not rains, actually if you are predicting, right, actually it's not possible because always statistics says 5% here and there, maybe 99% accuracy. There is no something called 100% kind of thing. So, right, if you are trying to make it very closer, that's called overfitting. Okay, how to build the machine learning model in use case? Okay, if you are using Python, right, actually you can go to PyCaret site, right? Actually there is a lot of samples available, right? Or go to Data Camp, which is having a lot of algorithms, a lot of stuffs available, and you can search for GitHub for AI/ML use cases, right? That's where actually you'll be able to build it. You can take the you can go to there are programming sites available, right? Actually, okay, to understand, okay, before going into algorithms, right, you need to get into Python, right? Actually, Python, pandas, NumPy, and data visualization library, basic programming skills. You need to do get all this stuff 2-3 months, right? Actually, maybe write the basic use cases: how to read the file, how to open the file, how to do the panda, how to filter the data, how to group it, how to do the mathematical linear algebra operations, etc. That you need to do. Then probably you can take the samples. See whether I can share some sites for your stuff. Okay, so see, I'm doing Tamil language recognition project. So far, doing the project data set are not available any site. Okay, so there is something called Madurai Tamil Sangam, right? Actually, they have a lot of data sets. Okay, probably you can reach out, and I will also search. Actually, maybe I'm not done extensive work on Tamil language recognition set. So you need a data set for language recognition. I'll try to do, and then I'll if possible I will get it. However, I'm not able to promise because it's not my area of already work for. I don't have many friends, those who are working on Tamil language project, but actually, so if I able to get it, I will definitely pass it to you. Okay, so casuistry, that's a really good, interesting question. So you have something called imputation, right? So suppose if some value is missing, if it is a number, what we can do was, you already know either you can use mean, mode, median, or average, right? Well, that's a mean actually. So either see whether you can use mean or mode, or mostly minimum maximum we cannot use, but actually mean or mode can be used, or we can just even you can segment the data. For example, if particular group, maybe you can use this kind of data. That is also possible. So we can impute the data, right? And so fine, how to choose? Maybe I already answered this question. How to choose the career in between data science and AI, right? Actually, see, okay. So if you are interested in working on maybe social media companies or maybe our internet companies, then probably AI is the best option. If you look for banks, if you look for traditional company, mostly they are not using very advanced techniques and all. Maybe they use with machine learning and AI, or the machine learning and data science itself. So, but actually, again, actually, maybe without classic ML, you cannot go to AI. So that's the crux. Okay. So what is strong AI? Actually, when you say strong AI, it's kind of ethical, right? Ethical AI, actually, in terms of fairness, maybe transparency and compliance, and again, without bias, right? All these things kind of strong AI. whether we can trust the results. That makes strong AI. See, one of the real estate company US, actually I forgot the name of the company, right? Actually they did algorithm, they put it in the value. After this COVID stuff, actually the values are drastically reduced. They purchased the houses, real estate in very heavy price. That company itself gone bankrupt because actually they are not evaluated the signals, etc. So that's where the challenge comes in. So whether it is trustable, which is against tampering or against market volatility, and maybe if something goes wrong, whether we are getting alert, quick correction can be done. All these things plays vital role, Savita. So okay. Okay, so so here actually whichever area domain we have interest, right, and whichever in that actually you can do this real whether the problem is real, right? Actually, real means actually whether it will be at least whatever segment the problem. Whatever problem you are taking, which cannot solve the entire world problem. At least if you are trying to solve the problem for 1,000 people, that should be worth it, right? So maybe current if you look at cutting edge technologies, maybe you can do for chatbot related application, or maybe you can go for any medical application, right? Actually that has more value. Medical suppose if you are building any diagnosis system, based on that actually doctor's time will be saved, and then maybe it's a kind of second opinion, right? Actually, if you have any medical friends, you can use that. Or you can do some video analysis, video search, and video related projects. All these things are really interesting. Suppose if you are interested on the statistics side, probably you can do best stock prediction kind of thing, or maybe credit scoring. So Lisa, actually cloud AI and edge AI. Edge AI is kind of cloud AI is a superset, and edge AI is within the cloud. It's one part of it, right? For example, for remote location data processing, etc. And that has a demand. Edge AI has needs a lot of experts. But actually, again, edge AI, you need to use some of the cloud services also, right? So transformers, basically it's a kind of unsupervised learning, right? Actually there is no when we say supervised learning, actually we need labels, right? We need the what is the actual value and then what is the predicted value comparison, then only it's kind of supervised learning. Yeah, nice question, Vijayalakshmi. Actually is there any definitely a lot of misunderstanding about AI, right? And because one thing is something is fancy, right? People are taking it, everything coming from data mining, then data warehouse is fancy word, then data lake, and then machine learning, data science, deep learning, then AI. Now mostly everything, whatever people are doing, even stuff, actually they're saying a fancy stuff is we are doing AI. Some of them really not AI, but actually they are quoting it as AI. So that's one thing. And AI cannot do everything, right? Because, for example, if you are making one decision, right? Maybe we can sure about it. Suppose if you are making sequence of 20 decisions, then if you are looking for result, what will happen? Even human cases, there will be some errors will occur. Lot of algorithms, maybe it's not one single algorithm, maybe 30-40 algorithms working together. If one algorithm goes for a task, right? Actually, then it's kind of biggest challenge. So completely completely relying on the human, right? Actually, that will be a challenge. Here, what we can say was actually, someone asked Bill Gates, if you clone you, right? If you clone you like similar to you, and then if you compete with that person, who will win? So Bill Gates said, actually, I am the original, right? So finally, actually, I have he is my clone. Actually, I'm the original. I will be able to beat him. I will be able to definitely win him. That's what actually he quoted. So here, and again, actually, even AI engineers, right? Actually, people are expecting whatever I covered. One person cannot do it, but we need to have the overview of what are all we are doing. But we need to pick and choose our area, either data engineering side or machine learning development side or deployment side, etc. We need to kind of develop. But currently we need to know. And then once you get some enough work, probably then you can get to there. So Lakshmi Priyadarshini, this is a really good question. So we can do the data masking, right? We can put, suppose if our phone number, we'll put some XXX so that actually will be last 4 digits, or for 3-4 maybe random digits we can mark it, or we can put the block symbol itself, right? We can show a portion of the text. Critical kernel, they will do that way, and then we can encrypt and store it, right? And we can access through passwords. All these are the ways we can hide it, or we can retain the privacy, and then we can give the need basis access. For example, if even actually company CEO, right? Actually, if he don't need to access all the data, right? Actually, whatever his function needs, actually only that portion of data should be allowed to view. So what will be the future of AI? Actually, that's really evolving. And one of the research, actually, now autonomous cars are coming in. Autonomous vehicle will be useful in the industries, factories, etc. So there is a research going on by inserting the chips, the Bergins, and some of the medical alignments will be Elon Musk and co actually trying to do, whether we can have the medical intervention and then whether we can cure long-term diseases and all. They are doing it, trying to do that. And so that's one thing. And similarly, actually the technology is very cheap, right? Actually now cost is coming down and down. Maybe IoT chips and all maybe now coming under 10 rupees, 5 rupees, etc. And you can have the IoT devices, IoT stuff will be coming on, and we can track the data, right? Objects tracking or mechanical, maybe all the stuff will be really interesting and useful. Especially the service, maybe in Tamil Nadu, we are going to get the drones, right? Actually, drone, even people cannot watch for 24 hours, right? So that's where actually it's kind of thing. Hi, Vidya.
Sir, good afternoon, sir.
Yes.
Sir, for me, one doubt, sir. Sir, how can we apply an optimization or meta heuristic algorithms for hypertune the parameters or own CNN during the image processing, sir? Especially in medical imaging.
Can you please repeat that question again?
How can we apply an optimization algorithms or any meta heuristics algorithms for hypertune the parameters or our own CNN during the image processing, especially in medical imaging?
Got it. Which domain you are working on?
Medical imaging, sir.
1 minute with yeah. Okay. So yeah, definitely. Thanks for all your feedback. Hope actually the session will be useful, right? Actually, thanks for joining, and then maybe so I'm also definitely enjoyed your working with you all, and really interesting stuff. So those who wanted to drop off can drop off. Those who have questions, maybe I can stay another 5-10 minutes, 10 minutes, and then I can just drop off. So Anita is there actually. So thank you, and thanks everyone. And any feedback before taking any questions? Maybe those who wanted to go off, anything can be improved, or anything what you like most or what you don't like. Okay. Yeah. Okay. Which area you are working? Which domain?
Medical imaging, sir.
Medical images. Which particular images? Maybe cancer or
COVID, sir.
Okay. So what you are trying to do there?
Now I am trying to make a classification. I develop one model with the like name con XGBDNN, which is a comparison of VGG16 plus XG boost. Now I create that model. Now I'm trying to develop or enhance that model with by using some meta heuristic optimization algorithms or any optimization to hyper tune my the parameters.
Okay. So with the COVID data, actually, COVID images, you are trying to find out, classify whether person having COVID or not, or what are all things you are doing?
I take actually my data set have COVID, normal, and pneumonia chest X-rays.
Okay.
From that, I classify whether the person is affected by COVID, pneumonia, or they are normal.
Okay. So you are doing classification or
Classification, sir.
Okay. Not clustering, right?
No, sir.
So you have labeled the data set.
Yes, sir.
Okay, these are all images belongs to pneumonia. These are all images normal. These are all images. It's kind of COVID, right?
COVID, yes, sir.
Okay. So you are using convolutional neural network. Actually, so how many layers are you are using?
Sir, actually, I create my own CNN with yes, sir. I create my own CNN. First, I pre-process my image with the data augmentation and doing some augmentations. Then I create my own CNN with sequential layer plus batch normalization plus max pooling. Like
correct. Actually, how many layers you are having?
Totally, there are just where I have to.
Okay, fine. Actually, here it's a kind of okay. So whenever hyperparameters tuning, right? Actually, there is an option. So which library you are using?
NumPy array. Sorry,
Okay.
which library? I am using. Okay, I am using a TensorFlow in Keras.
Okay, so even you can see some option available in H2A because actually it automatically tunes and gives to you because it will give the intuition how you can do the stuff, right? H2A actually you can download and then you can use it. That will give the stuff. Here whenever going for hyperparameter tuning, right? Actually we need to go. There are 5-6 parameters which is available, right? Actually based on that we can increase the layer or maybe we can go for iterations, epochs. How many epochs you are doing?
Now I done with 25, just 25 epochs.
Okay, 25. Yeah, you need to increase the epochs first. 25 is not enough.
Okay, sir.
So, how many data points you have? Data sets you have?
Total number of data sets you asked.
Yeah.
Totally, that means COVID plus normal plus pneumonia.
Yeah.
Moreover, above 2,500.
Okay, 2,000. It's kind of pneumonia. How much? At least 400, 500, 1,000 range, or maybe
sir, 550, sir. Pneumonia 550.
Non-COVID.
Non-COVID maybe above 450. I have COVID only 750 above COVID.
Okay, that's fine. Because sometimes what will happen was you will have only 100 for COVID and then pneumonia for 100 remaining normal patient. That won't work. Or maybe 1,000 COVID and then 900 pneumonia. Then normal will be okay. At least now yours is kind of matching. So, but 25 folks is not enough, right? See, what you need to do was actually at least you need to use Google. Are you using Google Colab?
I know, sir, but I can't use still I can't use.
Okay, you try to use.
I know about that.
Yeah. Try to use Google Colab and then go for at least increase it. Go for up to 1,000, 2,000 epochs, and then probably you'll get some idea. and then actually you can look at different options, right? Which will work and which will not work.
Okay.
And because actually I am not able to help you because actually we need to have the block diagram, right? Actually then and then the kind of little bit on the data set, then only we'll be able to suggest, right?
Okay.
So especially so that's
actually my doubt is there can you please give any tips or tips to select the which it is a best algorithms for optimization
actually that's a challenge, right? Actually because so you are having image feature as depth, queue, all the stuff data, right? With that only we are doing, correct?
Yes, depth, texture, and edge.
Maybe you are having low level features, and then we are tuning it. So here maybe this particular maybe I'm not worked much on the imaging related area, right?
Okay.
And whatever text remaining, see whatever areas I am working, maybe some of even there is no way we can have one single algorithm will work better, right?
Yes,
so you tried XGBoost, and then what you tried?
Sir, first I create one model like convex GPTN.
Yes. Yes, ma'am.
Sir, we can have a discussion, or I'll get the queries of Vidya and I'll send to you, sir, because the session is getting prolonged.
Sure.
I'll send you I'll ask her the queries and I'll send you.
I will just go through and then do.
Okay, sir.
So thank you, madam. Thanks for the opportunity, and thanks team actually for waiting, and then really good. So hope you guys are enjoyed.
Yes,
right?
Sir, it was an interesting session, sir. So we'll wait for vote of thanks, sir.
Sure, madam. Thank you, everyone. Have a good day.
Saying thank you is more than good manners. It's a good spirituality. It gives me an immense pleasure to thank our guest speaker, Mr. Narayana Swami Kanagasabai, Head of Data Science, Reven 360 Chennai, on behalf of our Department of Computer Application. Sir, your explanation on recent trends of AI and MI technologies made our participants to know more about it. Thank you for sharing your knowledge. The way you explain on real-time data, the career to build an AI and MI will make our participants to have a vast idea about it. We will surely take your words, sir. Work hard, be smart, and practice. Thank you, sir. Thank you, all the participants.
Sir, we appreciate your patience in answering our queries. Thank you so much, sir.
Thank you, ma'am. So thank you, everyone. So wish you all the best, guys. So actually, all the questions are really good, madam. Actually, that shows the interest. I'm really happy to have the questions, first of all.
Okay.
But unfortunately, what happened was actually I'm not able to see the window, and because when I'm in the presentation mode. So, but anyhow, finally it was answered. So, thank you, everyone. Thank you, madam. Thanks for the opportunity.
Thank you.
Have a good day.
Thank you so much.
Thank you, sir. We will begin our next section by 2 o'clock.